Assalamu alaikum students, how are you? Hope you will be safe and fine. Students, you know that we have started chapter 6 solutions and we have done till molarity. Today we are going to discuss about solubility, as you know that we are studying about solutions, and a solution is formed when a substance becomes soluble in a solvent. So, how you can define solubility? Solubility is the amount of solute that dissolves in 100 gram of a solvent at a particular temperature is called its solubility. For example, solubility of sodium chloride in 100 gram of water at room temperature is 35.7 gram. Right? Now, if we are discussing about solubility, how a solute becomes soluble in water? Obviously, until and unless solute and solvent, they will not interact each other, so a solute will not dissolve in a solvent. So, over here, now we will discuss about solute-solvent interaction that occurs according to a very famous saying of chemistry, that is, like dissolves like. Now, what does it mean, like dissolves like? It means that the substances which are similar in nature, which possess similar characteristics, they are soluble in each other, and the substances which are unlike, that means they do not possess similar characteristics, they do not dissolve in each other. To explain this, I will give you an example of methanol. Methanol is a polar covalent compound. It has partial positive and negative charges, just like water, that is also a polar covalent compound. So when we dissolve methanol in water, what happens? Opposite charges interact each other. Negative end of methanol will attract positive end of water. Similarly, positive end of methanol will be attracted by the negative end of water, that is oxygen end. This is how methanol becomes soluble in water. Similarly, sodium chloride is an ionic compound. It is composed of cations and anions. In case of sodium chloride, positively charged sodium ions, they are surrounded by the negatively charged oxygen of water, and negatively charged chloride ions are attracted by the partially positively hydrogen atom of water. This is how sodium chloride becomes soluble in water. But on the other hand, if we consider gasoline and petrol, that are non-polar covalent compounds, as they are not polar in nature, so they are not soluble in water, because both of these, they possess, water and gasoline, they possess opposite characteristics. One is polar while the other is non-polar. But gasoline and petrol, as both of these are non-polar in nature, so they are miscible in each other. So this is about how a solute becomes soluble in water if they have similar characteristics, similar intermolecular forces in them. Now we will discuss effect of temperature on solubility. Temperature affects solubility in different ways, like solubility may increase with decrease in temperature, solubility may decrease with increase in temperature, or solubility is not affected by the change in temperature. Now we will discuss these cases one by one. First of all, solubility increases with increase in temperature. For this, we will take example of potassium chloride. Solubility of potassium chloride at 20 degrees Celsius in 100 gram of water is 34.7 gram. But if you will add more amount of potassium chloride, what will happen? It will not be dissolve, it will settle down at the bottom. But if we increase the temperature, now the settled amount will also dissolve. Now increase the temperature up to 100 gram up to 100 degrees Celsius. At 100 degrees Celsius, 56.7 gram of potassium chloride will be soluble in 100 gram of water. So this shows that on increasing the temperature, solubility is also increasing. Almost all the usually ionic compounds, their solubility increases with increasing temperature, but there are some substances whose solubility may decrease with the increase in temperature. That is the second case, and for this a very known example is of gases. Gases are less soluble in hot water. When you boil water, what happens? You will observe bubbles start arising from the water. These bubbles are actually of carbon dioxide gas or oxygen gas, which on heating, their solubility decreases and they start coming out of the water. Similarly, fish feel stressed during summers in an aquarium. What is the reason? That in summers, solubility of solubility of oxygen in water becomes less, due to which fish feel stress. And the third case is of sodium chloride. Sodium chloride, basically solubility of sodium chloride is not affected very much by the change in temperature. It almost remains constant. So this is how solubility is affected by the change in temperature. Now we will discuss our last topic of this chapter, that is comparison of solution, suspension and colloids. What are solution? We already have discussed that solution is a homogeneous mixture of two or more substances having uniform chemical composition. While colloids, what are colloids? Colloids are basically heterogeneous mixture of tiny particles of a substance dispersed through a medium is called a colloid. Apparently, a colloid looks like homogeneous solution. In colloids, dispersed phase is called solute in solution, while the dispersion medium is like solvent in the solution. Colloids are generally opaque. Similarly, now come to the suspensions. What are suspensions? Suspension is a heterogeneous mixture containing particles large enough to be seen with the naked eye and clearly distinct from the surrounding fluid is called a suspension. A very good example of suspension is sand in water. When you mix a small quantity of sand in a glass of water, you can easily observe sand particles remain suspended at first. Then gradually they settle down to the bottom. Similarly, another example of suspension is antibiotic medicines. In antibiotic medicines, you probably you have read that shake it well before use. Why it is written? Because it is a suspension. If you will not shake it well, what will happen? Particles of medicine, they will remain settled down at the bottom and you cannot get good quantity of medicine. That's why instructions are there that shake it well before use, so that medicine can easily be taken in a proper quantity, as it is a suspension. Now, how we can compare the properties of solution, suspension and colloids? Solution, first of all, about its nature. that solution is a homogeneous mixture while colloids and suspension are heterogeneous mixtures. Then the second difference is about particle size. In case of solutions, particle size is very small, that is from 0.1 to 1 nanometer, while in suspension particle size is greater than 10 raised to power 3 nanometer, and that is why these particles are visible through naked eye. Then in case of colloids, particle size vary from 1 to 10 raised to power 3 nanometer. As this particle size is not very large, so in case of colloids, although it is a heterogeneous mixture, but it appears to be homogeneous. Then the third difference is about particle visibility. Particles in case of solutions are invisible by naked eye, ordinary microscope as well as electron microscope, as these are very small in size. While in case of suspension, particles are visible by naked eye as their size is large enough. And in case of colloids, particles are invisible by naked eye and in ordinary microscope, but they are visible under electron microscope. Right? Is it clear? Now come to the fourth difference, that is about their filtration, that whether these can be filtered or not. On the basis of filtration, what is the difference between solution, suspension and colloids? So, in case of solutions, particle can pass through ordinary as well as ultra filter paper, while in case of suspensions, particles cannot pass through ordinary as well as ultra filter paper as they are large enough. So they cannot pass through any kind of filtered paper. While in case of colloids, as their size is not very small, not very large, so they can pass through ordinary filter paper but cannot pass through ultra filter paper. Now the fifth difference, that is about scattering of light. In case of solutions, they cannot scatter light. Light can easily pass through the solutions, while in case of suspensions, they scatter light. And colloids as well, they have the ability to scatter light. Then the last difference is about their example, that is very necessary to quote. In case of solutions, examples, there are so many examples as you have studied, that sodium chloride dissolved in water, sugar dissolved in water, well water. These are the different examples of solution, as all these are homogeneous mixtures. While examples of colloids are fog and dust particles suspended in air. Similarly, milk, butter, cheese, jam, jellies, halwa, mayonnaise. All these are examples of colloids. And examples of suspensions are sand solution, right? So these are the different. Similarly, along with sand solution, you can have an example of limestone, that is insoluble in water. So limestone dissolved in water. These are the examples of suspensions. Now we have studied a lot about solutions. Solutions, they are very important, playing a very important role in your life also. That's why we have discussed solutions in so much detail. Like you have studied about solutions. So what is their importance? Like you can take example of air. A very good example, a very important component for your life. You breathe in air, right? If you will not breathe, what will happen? You cannot survive. So air is a solution. Air is a mixture of different gases like oxygen, nitrogen, carbon dioxide and other gases. Similarly, another important component for your life, that is water. Water, although it is a compound, but natural water which we are using in our daily life for drinking, for cooking, for washing, for different purposes. This water is not a single compound, it is a solution. It contains many dissolved substances in it. It contains dissolved oxygen in it. It contains many minerals dissolved in it. So you can have an idea that how much these solutions are important for your life, that very two important component for your life, that is air and water, they are actually solutions. Similarly, in your daily life, you are using different solution like commercial products like window cleaner, sanitary cleaner, shampoo, gasoline, kerosene. All these are liquid solutions, right? Similarly, most medicines, they are dispensed in solution form. Usually, most of the medicines, which are in syrup form, they need water to dissolve. They are actually a solution of different chemicals, right? They contain different chemicals in it, so they are also a mixture. We are also using different solid solutions. I have given you example of gaseous solution, that is air, and liquid solution, that is different medicines, liquid dishwash cleaner. I have given you examples of gaseous and liquid solution. Now come to the solid solutions. Solid solutions which we are using in our daily life is gold, that is used for making jewelry. It is not pure gold. It contains some amount of copper dissolved in it. Similarly, brass, that is a solid solution of copper and zinc, right? Steel is also a solution of iron, carbon, silicon, etc. As well as parts of aeroplane. They are also made of solid solution of metals such as aluminium and magnesium. This is what we are using in our daily life. Along with their use in daily life, we are using solutions in medicines as well. Like for filling your dental cavities, we use amalgam. What is an amalgam? As I already have told you, that amalgam is a solid solution of mercury and silver or tin. So you can have an idea that how much these solutions are important in our daily life. Thank you, bete. Allah Hafiz.